Have you ever wondered just how old Saturn's moons are? The answer is not as straightforward as you might think. Saturn has a grand total of 82 moons, and pinning down their ages is a cosmic puzzle that keeps scientists on their toes. Most theories suggest that these moons are as old as the solar system itself, about 4.5 billion years. Yet some of Saturn's moons, such as Enceladus and Titan, show signs of geological activity, hinting at a much younger age. The primary method of determining their age is through crater counting. The more craters a moon has, the older it is presumed to be. However, this method has its limitations, as it doesn't account for geological processes that might erase or alter the craters over time. As you can see, the age of Saturn's moons is a topic of ongoing research, full of intrigue and uncertainty. So, the exact age of Saturn's moons remains one of the biggest mysteries in our solar system. Did you know that it's still unclear whether all of Saturn's moons formed at the same time? A fascinating question, isn't it? Theories abound, each with its own set of supporting evidence, yet the mystery remains. One theory suggests that the moons formed from the same disk of gas and dust that birthed Saturn, much like a family, all born under the same cosmic roof. Proponents of this theory point to the moon's similar compositions and orbits as evidence. Another theory posits that the moons were once independent bodies, captured by Saturn's mighty gravitational pull. This could explain the bizarre mix of icy and rocky moons that orbit the planet. Yet another theory proposes a combination of both, some moons originating from the same disk, and others captured later. As you can see, the formation of Saturn's moons is a complex and intriguing puzzle. Each piece of evidence yields more questions than answers. Therefore, the formation of Saturn's moons continues to be a subject of hot debate among scientists. Ever pondered why Saturn has fewer large moons than Jupiter, its gas giant neighbor? Well, let's dive into this cosmic conundrum. Saturn, the ringed beauty of our solar system, boasts an impressive 62 moons. Yet, when we look at Jupiter, it trumps Saturn with a whopping 79 moons. Not only that, but Jupiter's moons are significantly larger in comparison. Theories abound as to why this is the case. Some scientists propose that it's due to the differences in the planet's gravitational pulls. Others suggest it could be related to the materials available during their formation. Yet another theory points to the possibility of large-scale cosmic collisions in Jupiter's past that may have resulted in more and larger moons. Despite these theories, no definitive conclusion has been reached. The size and number of moons around these two gas giants continue to baffle scientists and space enthusiasts alike. So, the reason behind Saturn having fewer large moons than Jupiter remains a mystery. Have you ever thought about why some of Saturn's moons have liquid water oceans while others are dry? An intriguing question that continues to baffle scientists and space enthusiasts alike. The discovery of oceans on Saturn's moons was a breakthrough that turned our understanding of the outer solar system on its head. Enceladus, Saturn's sixth largest moon, and Titan, its largest, are two such moons that have been confirmed to harbor subsurface oceans. But why do these moons have oceans while others, like Mimas or Rhea, are as dry as a bone? One theory suggests that it's all about the moon's size and its internal heat. Enceladus and Titan are larger moons, and their increased gravitational interactions with Saturn generate significant amounts of heat, enough to melt ice into water. This tidal heating could explain why these moons have oceans beneath their icy shells. On the flip side, smaller moons like Mimas might not generate enough heat to sustain an ocean. These moons are akin to frozen wastelands, with their surfaces scarred by countless craters and devoid of any signs of liquid water. But this theory isn't the end-all be-all. There are still inconsistencies that scientists are trying to iron out. For instance, Mimas is subjected to even stronger tidal forces than Enceladus, yet it's dry. So, what's the missing piece of this cosmic puzzle? The answer might lie in the moon's compositions or their geological histories, or perhaps we need a new theory altogether. But what we do know is that the ongoing research into these questions is as thrilling as the mysteries themselves. Each new finding, each new theory brings us a step closer to understanding the intricate dance of these celestial bodies and their surprising ability to harbor the life-sustaining liquid, water. Thus, the presence of oceans on some moons and their absence on others is another unsolved mystery. A mystery that continues to challenge our understanding of the universe and fuels our curiosity to explore the great beyond. What about life? Could there be life in the oceans of Saturn's moons? The notion of life as we know it is bound by our experiences on Earth. However, life elsewhere in the universe may not follow the same rules. As we probe the mysteries of Saturn's moons, the question of life in their oceans becomes a tantalizing possibility. These moons, particularly Enceladus and Titan, harbor vast oceans beneath their icy surfaces, and where there's water, there's the potential for life. But what kind of life could survive in such extreme conditions far from the warmth of our sun? Scientists believe that the ecosystems in these alien oceans could be similar to those found in the deepest, darkest parts of our own oceans. Life forms here on Earth that thrive in extreme environments, known as extremophiles, give us a hint. These organisms can withstand intense pressures, freezing cold, and complete darkness. They subsist on chemical energy derived from the rocks around them, a process known as chemosynthesis. In the same vein, life in the oceans of Saturn's moons could also be chemosynthetic. The gravitational tug-of-war between the moons and Saturn generates heat, melting the icy crust to form oceans. The ocean floor could be a hotbed of geological activity, spewing out necessary chemicals. This could create a rich, albeit alien environment capable of supporting life. NASA and other space agencies are keen on investigating these possibilities. Future missions to Saturn's moons are being planned with the intent to search for signs of life. These missions could involve drilling through the ice and sampling the ocean water, or even sending a submarine to explore these alien seas. So while we're yet to discover extraterrestrial life, the oceans of Saturn's moons are prime locations in our search. And even if we don't find life, understanding these ecosystems will expand our knowledge of the universe and life's potential beyond Earth. So, the potential for life in the oceans of Saturn's moons is one of the most exciting mysteries yet to be solved. Did you know that Saturn's inner moons are drifting away from the planet at an alarming rate? Yes, it's true. The moons of Saturn are not as loyal as we might have assumed. They are slowly but surely drifting away into the vast expanse of the cosmos. We've known about this peculiar phenomenon for some time, but the reasons behind it remain elusive. The most accepted theory currently is the tidal friction theory. This suggests that as these moons orbit Saturn, their gravitational interactions with the planet generate heat. This heat, in turn, causes the moon's icy bodies to deform, creating a kind of gravitational tug-of-war. The result? The moons are gradually propelled further away from Saturn. Yet the rate at which they're moving is much faster than what tidal friction alone can explain. Could there be other forces at play? Or perhaps our understanding of tidal friction is incomplete. Thus, why Saturn's moons are drifting away so quickly is yet another mystery that scientists are trying to solve. And let's not forget about Saturn itself. What's the deal with Saturn's rings? Well, we might think of Saturn's rings as a timeless fixture of our solar system, yet their origin and age remain one of space's most captivating mysteries. These iconic rings, composed of countless particles ranging from tiny dust grains to massive icebergs, are a celestial phenomenon that has intrigued scientists for centuries. One of the prevailing theories about the formation of Saturn's rings proposes that they are remnants of a disintegrated moon. This moon, which could have been as large as Titan, Saturn's largest moon, might have ventured too close to the planet, causing tidal forces to rip it apart. The debris from this cataclysmic event then settled into a disk around the planet, forming the rings we see today. Another hypothesis suggests that the rings could be much younger, perhaps only 100 million years old. This theory posits that the rings formed from the icy debris left over after a comet or asteroid collided with one of Saturn's moons. But here's the catch. While these theories are compelling, none can definitively explain all the intricate details observed in Saturn's rings. The varying composition and coloration of the rings, the strange gaps and divisions within them, and their surprisingly dynamic nature, all pose challenging questions that remain unanswered. Scientists today continue to probe these enigmas with the aid of advanced spacecraft like the Cassini mission, which spent 13 years studying Saturn and its rings. Through such missions, we're discovering that the rings are not static, but are constantly changing, with new material being added and old material being lost. The study of Saturn's rings isn't just about understanding their past, but also predicting their future. Some scientists predict that the rings are gradually disappearing, with ice particles from the rings raining down onto Saturn's atmosphere. At this rate, the rings might vanish entirely in about 100 million years. So even Saturn itself, with its iconic rings, holds mysteries that scientists are striving to understand.